In section 2.5, excuse me, we're going to talk more about measures of position. And there are different ways that we can measure position of the data set. So one of the main ways we talk about are quartiles. We've actually talked about position already, but focused on things like center, right? So here we're going to talk about other positions in the data set. And quartiles are one of the most common ways that we can do this. So in this section, we will learn how to use fractiles to specify the position of a data entry within a data set. And fractiles are numbers that partition or divide an ordered set into equal parts. So again, one of the most common ones are your quartiles. So there are 3 quartiles, Q1, Q2, and Q3, and they divide an ordered data set into 4 equal parts. About 1/4 of the data falls on or below the first quartile. About half of the data set falls on or below the second quartile. And the second quartile is also the same thing as the median, so it's that center. And then about 3/4 of the data fall on or below the third quartile. So if you have your data set here, okay, like let's say this is your min and your max. I'm going to assume it's kind of symmetric just to make it easy. Well, your median is in the middle, and this is your second quartile. And then your first quartile is here, and your third quartile is here. So those the quartiles break everything up into 1, 2, 3, 4 parts. So it basically represents like the 25% mark, the 50% mark, the 75% mark in the data. So let's look at an example. Each year in the US, automobile commuters waste fuel due to traffic congestion. The amounts in gallons per year of fuel wasted by commuters in the 15 largest US urban areas are listed below. Find the first, second, and third quartiles. First, do it by hand, and then go ahead and use technology and do it there. So when you're finding quartiles, by hand, the first thing you need to do is order your data. Okay. So I'm going to go ahead and look and try to order this data. And my smallest value is 11. The next value I have is 20. Then I have 22. I have 23, 24. And let's see, I have 3 25s, 28, 2 29s, a 30, 33, and 2 35s. Now, I've already done this problem out beforehand, but I just put things in order. So I'm going to go one at a time, find the minimum value, okay, what's the next smallest value, and so on, and just order that data by hand. Now, the first thing I'm going to find is my second quartile, because that's my median. I'm going to find this guy first, because you already know how to find the median. It's the middle of the data. So I'm going to count in. Actually, I'm going to just use like a light color to help me. So I'm counting it towards the center here. I do see I have a value right in the center, that 25. So that center value here, this is your median, which is the same thing as your second quartile. They're the same exact value. So 25 is the answer for quartile 2. Now what happens actually is your first quartile is sort of kind of focusing here. The middle of the first part of your data, and then your third quartile is the middle of the second part of your data from that median. So Q1 is the median of the first half of data, and Q3 is the median of the second half of the data. So that's an easy way that we can find it by hand. So I'm just going to kind of do the same idea again with my first half of the data. So I count in 1, 2, 3, and there's my value here. So that is my Q1. And then here, 1, 2, 3, and there is my 3. So my first quartile is equal to 23. My second quartile is 25, and my third quartile is 30. So what this means is basically that about 25% of the data lie at or below 23. About half the data lies at or below the value 25. And about 75% of the data, or 3/4 of the data, lie at or below the value 30. Okay? So when we say a quarter, you can also think that that is 25%. When you say a half, you can also think of that as 50%. And when you say a 3/4, you can also think of that as 75%. So whatever kind of works better for you to interpret that. Okay, so it's the position in the data. Now we can find it very easily on our calculator, and you actually know how to do this. So here's my calculator, and the first thing you always have to do is enter your data. So I've already done that. I hit stat, I hit edit, and I entered my data that was right here. Now, I don't need to sort it. I can if I want to, but I don't have to sort it. All I need to do is go back and do that one var stats procedure that we've done for the mean, the median, and the standard deviation already. It's all there together, which is wonderful. So I hit stat again. I go over to calc, and I do one var stats. And then it's always going to use L1 unless you change that. So I can just hit enter, and it's going to give me my values. Now, there's my mean. My standard deviation is going to be here. Depending on if I'm using my sample or my population. But then on the right, you have your quartiles. You'll see Q1. The median is the same thing as Q2 and Q3, and those are the same values we got. 23 for Q1, 25 for the median or Q2, and 30 for Q3. So they're all right there. So this one var stats is like my favorite calculator technique because you get so much information in one shot. And we're going to use it like we're always finding like means and medians and standard deviations and quartiles and things like that. So we're going to use it all the time. It's a great one. So there are your quartiles using technology. You can also do it in Excel. So let me show you that too before we go on. So again, I already entered the data into Excel to save us some time. Now, I will warn you that different technologies compute quartiles a little bit differently. So we kind of just did it by hand here, just by finding that median and counting in. But there are different ways to compute it, whether you include or exclude n values. So if you find in technology that you're getting slightly different answers, it may not be that you did anything wrong. It's just that the formulas could be slightly different. So for Excel, they also have different formulas, but the one that your book suggests using is this one. So you start typing in the word quartile. Okay. Now, you do have two options. You have quartile exclude and quartile include. So again, this is why you could get different results for your quartiles. I'm going to follow along with your textbook and just kind of stay in line with them. They recommend using the quartile include one, so INC. Okay. Or I should say inclusive. So you're just going to double click that. And this is what you have to do. You have to first select your data. And now it gets a little bit different. You're going to put a comma, and then you're going to write the number 1 for the first quartile, the number 2 for the second quartile, or the number 3 for the third quartile. And it kind of tells you right there. It kind of gives you the hint there, right? First quartile, second, or third. So you're going to either type 1, 2, or 3. So if I want the first quartile, I'm going to type 1. Then I'm going to hit enter, and it returns the first quartile here. So notice that our value was 23. This one is 23 and a half. So again, you get slightly different results with different technologies. So I'm going to do it again here. Again, I'm using the include one because that's what your textbook recommends. So I'm going to stay in line with them. But the include and the exclude one are both good. They're both correct. It's just different ways to compute them. This one I'm going to put a comma and put 2 to get the second quartile. So 25 matches exactly what we had. Don't forget to always start your formulas with an equal sign, or else it won't work. And again, I'm going to highlight my data, and this time I'm going to do a comma, and then, a comma, and then a 3, and that will give me my third quartile. So this one gives us 29 and a half. We had 30. So both all correct, just slightly different ways to go ahead and do that. Okay. Now, With the quartiles, you can actually compute something else as well, and this is called the interquartile range. And the interquartile range tells you how spread out the middle half of the data is. So you kind of just focus on the middle of that data there. And it's very easy to compute. All you need to do is take your third quartile and subtract it with your first quartile, and that gives you your interquartile range. Now, why is the interquartile range useful? And that's because it helps us identify outliers. So I've been kind of mentioning that there is a more systematic way to find outliers without just us guessing and saying, oh, that looks kind of far away. And this is the way you can do it. We can use that interquartile range. So what you do is you find your interquartile range and you multiply it by 1.5. And then what you do is you subtract that value from Q1 and you add it to Q3, and that gives you your bounds for what would be usual for data points. So anything beyond that bound be considered an outlier. So let's use the same data from example 1 because we already have it all done. So let's see, our quartiles were 23, 25, and 30. And let's see if there are any outliers in our data set. So first thing I'm going to do is find that interquartile range. So I take Q3 and I subtract it with Q1, and I get 30 minus 23, which is 7. And then I take that value and I multiply it by 1.5. Okay, so I'm just going to go ahead and do that, and I should get 10.5 there for my value. And it just froze for a second. There we go. All right, so now what I do is to find my bounds, I'm just going to make almost like a little chart for myself here. Okay, so my lower bound is going to be Q1 minus that 10.5, and then my upper bound is going to be Q3 plus 10.5. So my Q1 is 23, so I do 23 minus 10.5, and I'm going to go ahead and get 12.5. And then for Q3, I have 30 plus 10.5, and I get 40.5. So anything outside this would be an outlier. So either bigger or smaller. So if I go back to my original data and look here, so my smallest value was 11. That is definitely less than 12.5. So that value of 11 is an outlier. It's smaller than 12.5. On the other end, I have 40.5, and all my highest value is 35, so I don't have anything on that end. So it looks like then 11, the data point of 11 is definitely an outlier. And we may have seen that ourselves, right? If you look at the data, you probably say, oh, that 11 looks a little bit different than all the others. But now we have an actual formal way to say that, yes, that is really an outlier. We're not just guessing that it looks different, right? We're showing that numerically speaking, mathematically speaking, it is different. Now, there is a nice graph that we can make using these quartiles, and it's called a box and whisker plot, or usually we just say box plot for short. And it just helps us to get an idea of what the data looks like, and it highlights some important features of these numbers. So it uses what are called the five number summary. So what you need to create it is the minimum data point, the maximum data point, the median, which is Q2, the first quartile, and the third quartile. And when you put these 5 numbers together, we call this the 5-number summary of a data set. And we can create a graph with that. So notice that your graph looks like this. So you paint a straight line across the whole thing. You start at your minimum value and you end at your maximum value. And then you plot Q1, Q2, and Q3, and then you just draw a box around your quartiles. And basically this is showing you, so this right here is the middle 50% of your data. So that box contains the middle 50% of your data, and then this is 25%, and this is 25%. Okay, so it just kind of shows you where that middle piece is, the core of your data. And it kind of gives us an idea. So this one looks, it's not quite symmetric, right? This left side looks to be a little bit longer here. So you, again, it's similar to the idea of a histogram where we can kind of see if data looks skewed or if it looks symmetric. If you have a nice kind of rectangular box and everything looks to be a mirror image, then your data is also symmetric. If you see one end that's maybe really long and kind of away from the that box, then you may have like an outlier or something like that. So it just kind of helps to give us a general idea. Now, how can we draw this? It's actually pretty easy to draw. So again, we're going to use example 1. Now, if I go back to example 1, I did see the minimum value was 11. Let's see, we saw that Q1 was 23. Q2 was 25. Q3 was 30, and my highest value was 35, I believe. Let me just double check. Yes, 35 was my max value. Now, when you draw your box plot, you just want to make sure it is to scale. So you're not just putting in a line in a box and putting numbers wherever you want them. It does have to be on an actual number line, which is really important. So my minimum value here is going to be 11. All right, so it's going to be, let's say this would be 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I need 23. This is my quartile, first one. 24, 25. This is my second quartile or my median. 26, 27, 28, 29, 30. So this is Q3, 31, 32, 33, 34, and 35. So actually I got to end it right there, which is my max. Okay, so I'm just doing by hand, so I know it's not perfect, but you do have to do it to scale. And then what you're going to do is put a box around those quartiles. So there's our data. We can see it really doesn't look symmetric at all, right? So it does look like here's our median in the middle, so the data does not look symmetric. We also see that this tail is really long, and we actually found that this was an outlier already, right? So we did see that that was already an outlier here. But like I said, what it's showing you is about 50% of, or exactly 50% of your data is in the middle here. About 25% of your data is here, and then about another 25% of your data is on the right there. Now, your calculator can also do box plots for you. So I'm just going to bring my calculator back up here. And again, you always have to start by entering your data. So I have the data already entered because we've been doing the same problem. And what you're going to do next to graph it is you're going to hit second, and then the Y equals button so that you're selecting stat plot. Now, what you want to do here is make sure one of your graphs is on. So you can see my first one is on its green while the others are X's. And then you do need to change your graph. So you probably already have it as a histogram because we did that last. So what you're going to have to do is either use your up and down keys or scroll through and select the one that looks like a box plot. Now, there are two kinds of box plots. So this one is your more standard one, which is how the one we drew. This one here that has the dots next to it, there's a second way we can do box plots where if there's an outlier, we actually draw it slightly differently. We put a dot on the outlier, and then we end the graph at the lowest value before that instead. So basically what it looks like instead is you'd have a dot here, and then you would kind of have your graph instead go this way. Okay, so I'm just kind of mimicking the one that's above. So this is another way to do a box plot, is if you know you have an outlier and you really don't want to focus on it, is you can still draw that outlier, but then what you do, our next lowest value was 20, is you kind of pretend like it's not there and you draw the box plot with your next lowest value. So you can do that on your graph here as well. So if you see a box plot that has little dots next to it, that's this style instead. So you can just select the one you want. You want to make sure your X value is on the correct list. And you do want to change the second one. Your frequency should be on 1. You're going to hit done, and then you're going to hit graph. And to see it, you probably won't see it when you initially graph. You need to hit the zoom button and make sure you hit zoom stat, that it goes to the statistics graph. And then you can see it here. So you can see that there's my box plot, standard one that we just did, and your calculator can do it for you as well. So if you're doing homework questions and you already have your data in here, it's pretty quick to go ahead and do that box plot. But they're also easy to draw by hand, and just to kind of check to see if it's accurate or not. So that would be the 5-number summary. So your quartiles, and then your min and max value, and then also the graph that we can get from that.